Now, so this topic here, okay, heat energy shouldn't be too difficult, okay, but some people do struggle with this. Okay, I'll be putting in, some videos for you to watch as well as we go through this. Okay, firstly, you need to know this, right? When there is heat, right? Okay, when there's heating taking place, usually there'll be expansion. So what is expansion? Increase in the size of objects. And then on the other hand, right, the opposite, cooling. Okay, when cooling takes place, usually there'll be a decrease in the size of objects. Okay, now expansion and contraction in daily life. This is something that you need to know. You need to quote some examples in your assessment, right? So like SMRT tracks, we have these small gaps, okay, along the tracks to allow for expansion. And then bridges as well, okay? There are these expansion gaps to actually allow for certain movement. Okay, now, how do you measure temperature? We use thermometer. SI unit is actually Kelvin. Okay, even though the one we commonly use in Singapore is degrees Celsius, but the international standard unit is actually Kelvin, capital K. Bimetallic strip, something you need to know. Have you all already learned about bimetallic strip? If you have, put up your hand. If you have not, okay, then listen to this part. Okay, Jeet already learned this. Now, bimetallic strip, okay, is made up of two metal strips. Okay, so if you see this example I have, right, one side, the gray color one is steel, then the yellow one, you can either use brass or copper. Why are there two different metals? Because metals expand and contract at different rates. Some expand more, some expand less. Okay, so the similar thing also happen for the opposite. If they contract more, it also means they have expanded more. Something like that. Something that can expand more under heating will also contract more upon cooling. So we use bimetallic strips in thermostats. Okay, we also use it in bimetallic thermometer. One very good example will be the aircon unit. So when you actually fix your air conditioner at maybe 24 degrees Celsius, sometimes you feel that it's blowing a lot of cool air, right? Then sometimes it stops. Why is that so? Because there's a bimetallic strip inside the thermostat that will determine whether the aircon needs to work to cool down the room, or it can take a rest because the room is cold enough. Okay, because it continues blowing cold air, what will happen? You will feel colder and colder and colder. All right, so we set it at 24. We want it to be around 24, although it cannot be exactly 24 all the time. Sometimes it's a little bit warmer. When your room gets slightly warmer, okay, then the aircon needs to work again, right? The thermostat will help to determine whether it needs to start working and produce more of the cold air. Okay, so take a look at this part.
This is a demonstration of thermal expansion.
Can you hear this? Hold on.
What I have here is a bimetallic strip with one type of metal on one side. It looks to be brass or bronze, and another type of metal on the other side. These two pieces of metal are attached, adhered to each other, and when you heat this strip, these kinds of strips are used for switches, thermostats, this sort of thing. When you heat the strip, given the fact that the two metals will have different thermal expansion coefficients, one will expand more than the other, and it will curve, the strip will curve. So I'm heating on both sides to convince you that I'm not cheating by just heating one side and having it expand. So that is a bimetallic strip.
Okay. All right, so that's how the bimetallic strip works. Right, so when you actually cool it down, okay, depending on the temperature you cool it down to, if it's to room temperature again, it will go flat. But if you cool it further below room temperature, okay, it will curve the other way because contraction will happen. All right, so the one that expands the most will also contract the most. Okay, so that is how this works. Now, another video I want to show you before I continue is this one.
Whenever an object is heated, energy is transferred to its thermal energy store, and its temperature increases. The process of heating, though, can take place in 3 different ways, depending on the medium involved. For solids, heat is transferred by conduction. In fluids, it's via convection. And to get through empty space, heat has to be transferred in the form of radiation. Let's start with conduction. The key idea behind conduction is that vibrating particles transfer energy to neighboring particles. To understand how this works, let's imagine that you were heating one end of a piece of metal with a Bunsen burner. And imagine the piece of metal as a series of particles. As the end of the metal is heated, energy is transferred to the metal, or more specifically, is transferred to the kinetic energy store of the particles at that end. This causes the particles to vibrate faster, and so they collide with their neighboring particles more often, and with more energy. As the collisions transfer kinetic energy, the neighbors will also vibrate faster, and collide more with their neighbors. And as this process repeats, energy is passed along the piece of metal, until in the end, the heat is spread out evenly, and it will be pretty much the same temperature everywhere. Now, the reason that conduction occurs mainly in solids is because the particles in a solid are held together really closely, which means there's lots of collisions that pass on the energy. Whereas in liquids and gases, the particles are all further apart, and so they don't collide as much. Exactly how well objects transfer energy by conduction is known as their thermal conductivity. Metals have a high thermal conductivity and transfer heat energy rapidly, whereas plastics have a low thermal conductivity, which is why we use them as insulators. And pretty much all fluids have a low thermal conductivity. Convection, on the other hand, occurs mainly in fluids. And remember, fluids can refer to anything that can flow, so both liquids and gases. Because the particles in fluids aren't fixed, once they're heated and they gain kinetic energy, they all move around faster. By the process of random diffusion, this will cause these more energetic particles to move away from the warmer region towards the cooler region. And overall, this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. So effectively, the fluid in the warmer region actually expands as it heats up, and so becomes less dense than the cooler fluid. To understand how this works in real life, let's imagine that we had a container of fluid. So that could be either liquid or gas. As we heat the container, the following things would happen. First, the particles near the heat source would gain kinetic energy and spread out, becoming less dense. Because they're less dense, these particles rise above the colder, less dense particles above them. And at the same time, these cooler particles sink down and take their place. Whilst this is happening though, the hot particles would lose their energy and cool down, and the cool particles now at the bottom would heat up. Because of this, the cycle would keep on repeating for as long as the fluid was being heated, and we call this cycle a convection current. We actually see these convection currents all over the place, from oceans to inside buildings, where radiators warm the nearby air and set off the cycle. On the other hand, to reduce convection, we need to stop the free flow of fluids, which is all we're doing when we sleep under a blanket at night, which is stopping the warm air from escaping. What conduction and convection have in common is that they both involve particles gaining kinetic energy. It's just that in conduction, only the energy is transferred between the different particles, whereas in convection, the particles themselves move. However, heat energy can also be transferred without particles, which means it could travel through a vacuum. This happens when energy is transferred by radiation, and specifically when the energy is carried by infrared waves. All objects constantly absorb and emit radiation, and in reality they do both at the same time. Importantly, the hotter the object is, the more radiation it emits. This is why it feels hot to put your hand over a barbecue, even if you're not touching it. The very hot metal and coal is emitting infrared radiation, which is absorbed by your hand. We take a closer look at infrared radiation when we cover the electromagnetic spectrum. Anyway, that's all for today, so hope you enjoyed this video, and we'll see you next time.
Okay, so you just saw the video explaining conduction, convection, and radiation. All right, it's a short video, just like a quick summary. Now, when you learn this topic, okay, some of you have not learned this, right? Okay, so you need to understand these three different ways how heat is being transferred. First way is by conduction. So it's actually transfer of heat through a material without obvious movement of the medium. Okay, the particles do not move. All right, so you saw how the heat is actually being transferred from one end to the other end. So the particles are heated at the beginning, okay, and then the energy is being transferred down to the next particle, etc. So the neighboring particles keep getting the energy until the entire material gets heated. Okay, so you need to know good conductors. They are the metals, for example. Poor conductors, liquids, gases, and some solids, right? Uses, okay, what is conduction used for? Example, ironing clothes. Bottom of the electric iron is made of steel. Why is that so? Because it's a good conductor. It can help to conduct heat to the clothes that you're ironing. Oven mittens, if you are baking, right? Okay, you use oven mittens because it contains trapped air. Since air is a poor conductor, heat cannot actually be conducted easily, okay, through the mittens and then reach our hand and burn our hands, okay? Now, convection, right, is a transfer of heat from one place to another by the movement of the medium itself, like the particles. If I were to just talk about, maybe I give example this way. Okay, imagine how many of us here, there are 6 of us here, right? Okay, so 6 of us. If I were to illustrate this way. So this is me, okay? All right, then maybe we can have Daniel here. Daniel being first, okay? Then followed by Jit, and then followed by Lincoln. And Rainy. And then this person will be Sherman. So Daniel has this book that he needs to pass down. Okay, he needs to get this book to me, right? So conduction is like he will pass the book this way, okay? Then Jit is going to pass down the book to Lincoln, and then to Rainy, to Sherman. Sherman will then pass the book to me. So imagine this book is like the heat. Okay, so it's being passed this way. Must come to me, right? So this is conduction. Conduction means none of us move. Particles are not moving. It is this energy that is being transferred. Imagine the book is the energy. It's being passed down to the next particle, until it eventually reaches the end. Convection is a different thing. Convection, particles will be carrying the energy and moving, right? Correct. So Daniel will then be carrying the book. Instead of passing down,